This question is asking us to write the Lewis structure for ammonia, determine its electron domain, and molecular domain geometry. So first off, we know that NH3 is ammonia. And if we go ahead and count how many valence electrons there are total in NH3, we know that nitrogen has 5 electrons in its outer layer, so 5 valence electrons. We know that hydrogen, we have 3 of them, is going to have 3 valence electrons, because 1 each, and then in total it's going to be 8 valence electrons. So if we go ahead and write it all out, we're going to have nitrogen, and then we're going to have 3 hydrogens off of it, so 1 hydrogen, 2 hydrogen, 3 hydrogens, and each single bond is going to go ahead and count as 2 electrons, so we can go ahead and 2, 4, 6, and subtract that out of the total valence electrons. So now we're left with 2. It's important to note in this problem that hydrogen is happy with 2 electrons in its outer shell. It's one of the 3 exceptions to that. So they're actually happy with that, so they don't have to have a full octet. So 2, 4, 6, all hydrogens are happy. Nitrogen needs 8 in its outer layer, so it has 2 here. This makes 4, and this is 6, so it needs 2 more, and then we have 2 valence electrons left. So we can go ahead and put it right here as 2. So then, now we have to go to our chart to determine the electron domain, and we know that it has 1, 2, 3, 4 electron domains, and that's going to be tetrahedral, so it's going to be shaped tetrahedral. And then to determine its molecular geometry domain, we know that it has 1, 2, 3 bonding and 1 unbound pair, and that's going to equal trigonal pyramidal, and that is the Lewis structure, electron domain, and molecular domain geometry for ammonia.